Hello guys, and welcome back to another geography lesson. Today we're going to go look at question number 2. In the previous lesson we looked at question number 1. Now keep in mind you only need to answer one question out of section A and section B, and then do another question either section A or section B. Only do 3 questions. Okay, do not do all 4 of the questions. But let's get straight into it and go and look at question number 2. Now, question number 2 referred to city climates. Now, when we look at city climates, we look at urban heat islands and we look at pollution domes. Now, as you can see over here, we have a CBD situated over there. Okay, our residential areas over there. We've got an inversion at number A, what we can see over there, and we got the sun rays you can see reflecting from the buildings over there and being absorbed by the buildings. So let's just quickly look at the questions that's being asked regarding the city climate over there, and we'll see what it represents. Now, our first question, the sketch shows a day or night situation, and the correct answer will be definitely day. Why do I say day? Because they mentioned sun rays. We don't see the sun shining at night. So definitely the correct answer will be day. Okay, our next question. The inversion layer is found at a higher or lower altitude during the night. Now what happens during the night? It will definitely be a lower altitude, because what happens is going to be a stronger subsidence because of cooling temperatures. The inversion will be lower. If you look back at the temperatures over there, now there will be a stronger subsidence during nighttime because of cooler temperature. So that means the inversion layer will be lower. Okay. If you look at our next question, just want to write there lower. The inversion layer increases or decreases pollution concentration over the city during the night. Now, definitely the correct answer is increases, because what happens over here, there's a stronger subsidence taking place. The inversion layer is lower. So what happens? All that pollution that's being created by the CBD is trapped below that inversion layer, increasing the pollution levels below the inversion layer. So the correct answer over there is increase. Now 2.1.4, the heating of the city at B is the result of multiple reflections of heat or terrestrial radiation. Now if you look at the diagram, you will see that there's multiple reflections taking place, incoming solar radiation bouncing off the buildings because of the type of surface, as you can see over there. So that will be the correct answer. Terrestrial radiation is the earth cooling down, can only absorb so much, so that will be the correct answer will be multiple reflections of heat. The channeling of wind between the tall buildings, what does it do? Does it increase or decrease the wind speed? It definitely increases the wind speed between them, because they can only move in one direction. Okay, so because the infrastructure creates obstacles for the wind and channel the wind in only one direction. 2.1.6, temperature increase or decrease from B to C. Let's quickly have a look from B to C. So from there, B to C, what happens with the temperature? There's a CBD, there's the rural or suburban areas. Definitely what happens to the temperature? It decreases. Why does it decreases? Because if you look at the residential areas, you will find more green belts, you will find more open water surfaces. Remember, a lot of artificial heat are being generated in the CBD area over there. So let's quickly go back to our question, and the correct answer will be decrease. Now the influence of evapotranspiration on cooling the air will be less or more at B compared to C. It will be less, definitely less. Now I've mentioned that if you compare B with C, evapotranspiration will be much more at C because there's more vegetation cover than in B, and there's more open water surfaces at C than in B. So the correct answer will be less. 2.1.8, area B is associated with more or less cloud cover comparison to area C. Now let's go back to area B. Now they reckon that area B will going to have more or less cloud cover. There's going to be more cloud cover at area B, and I'm going to draw a little cloud on here, because the simple reason why is because we experience a country breeze, and there's more rainfall in urban areas such as CBDs because of the rising air that takes place. But where does it get its moisture content? It's being sucked in from the surrounding rural areas, creating a country breeze, and the air cools condensed clouds and rain, usually over the CBD. So the correct answer for question 2.1.8, there will be more cloud cover at B than at C. Okay, that was our short questions. Let's quickly continue to our next set of short questions over there. And if we look at 2.2, study figure 2.2 showing 3 types of rivers named X, Y, and Z. Now, as you can see, there's X, Y, and Z. Now, if you look at it, there's a dotted black line that shows us the water table during wet season, and then there's an even finer dotted black line showing us the water table during dry season. So immediately, what do we know? We've learned in geomorphology about our 3 different rivers. Now, before the grade 12 syllabus, you knew about 2 rivers, perennial rivers and non-perennial rivers. But now, today, you know about exotic rivers, periodic rivers, episodic rivers, and permanent rivers. So let's quickly have a look at the questions that follow. Which river, X, Y, or Z, is episodic? Now, episodic, the correct answer will be X. Okay, if you can look at it, the water table during the wet season, well below where the water is. Now, water table during the dry season, also well below. Episodic, only flow after flash floods. So your correct answer will be X. Okay. Which river, X, Y, or Z, flows only in the rain season? And that will be a periodic river. But let's just go and have a look which one is the periodic river. And that will be Y. Because look over here, this is during dry season. But look at rainy season, there's going to be water in it. That's our non-perennial rivers. It's only flowing seasonally. Okay, so the correct answer over there is going to be Y. Now, which river, X, Y, or Z, is dependent on surface water only? Now, keep in mind, it can't rely on underground water. Only to water that falls to the ground is precipitation. And the correct answer over there, you can see only to the surface, that's going to be river X. If you look over there, only depends on the surface water. Now, which river X, Y, or Z flows throughout the year? That's our permanent river or perennial river. And if you go back to the diagram, you can see during dry season there's water in the river, and during wet season, obviously the river is going to flood. It's floodplains, and the correct answer over there is going to be river Z. Now, which river, 2.2.5, X, Y, or Z, flows only for a very short period of time, and that's also going to be River X, because the water dries up very quickly as soon as there was a storm that took place. 2.2.6, name the river X, Y, or Z in which the water table intersects the channel throughout the year. And the correct answer over there is Z, is the permanent river. As you can see, even during dry season, the water table intersects the river bed, as indicated on the figure over here. And then our last question, 2.2.7, which river X, Y, or Z displays the biggest change in water levels between seasons? And that will be River Y, because that's experienced seasonal rainfall. If you look at it, why? During wet season there will be water. The river will be a non-perennial river. There will be water in the river bed, but during dry season it will be completely empty. And that's how we managed to get to the correct answer. Okay, that was the short questions for question 2. Now let's quickly continue with 2.3. Study figure 2.3, which shows the influence of slope aspect in a valley in the southern hemisphere. Now, first of all, what do we know about slope aspect? Very importantly, I just want to, if we look at aspect, very importantly, if that's our north-facing slopes, our south-facing slopes, our north-facing slopes receive direct insolation. Our south-facing slopes are usually casted in a shadow because it's not direct insolation, and people tend to live on the north-facing slopes because they are warmer than the south-facing slopes. And as you can see over there, there's north and there's south. As you can see, this is a north-facing slope, that's a south-facing slope on the inside. So let's quickly have a look at the questions that's being asked regarding slope aspect. Now 2.3.1, define the term slope aspect. Okay, it's basically the direction which the slope is facing in relation with the sun rays. Okay. Now, if you look at the figure, which slope in figure 2.3 receives the direct rays of the sun or insolation, and that will be the north-facing slopes. I will go back to the diagram right now. The north-facing slope because as you can see, remember this is a slope over here, this slope is facing towards the north, and as you can see, have a look at the incoming solar radiation, check out the shallow zone, like basically that I've explained to you down there. Refer to the slope labeled shallow zone in the picture. Give a reason for the high moisture content of the soils on this slope. Because they're in the shallow, they receive lower temperatures, and it means because of they have less insulation, it means that there's going to be a higher moisture content. It's not going to dry up very quickly. So what can we write down there? Give a reason for the high moisture content of the soil on this slope. I just want to show you where this shallow slope is over there, because they don't receive that much insulation. So what can we write down there for the correct answer? We can write the following. So they experience lower temperatures in the shallow zone. There's lower evaporation rates because there's less insulation, direct insulation. And doesn't receive direct insulation. Okay, just write there doesn't. Okay, there's 3 reasons why it's got a higher moisture content. Now, if we look at question number B, why is there a lack of human activity in the shallow zone despite the high soil moisture content? Obviously, the slope is, as you can see, if you compare the shallow zone to the north-facing slope, you can see that it's got a steeper gradient, and because it's got a higher moisture content, there's going to be more damp being experienced, and definitely the shallow zone is going to experience cooler temperatures. So let's quickly go and write down in our findings that we got from our figure. So because of cooler temperatures, in the shallow zone, we can also say because of dampness being experienced because there's more moisture, and lastly, you can see the gradient is quite steep. So I'm just going to write a steep gradient. Okay. Now give a possible reason for the location of the farmhouse on the valley floor. Now, as you can see, if we go back to the farmhouse, look at the location over there. There's the farmhouse situated almost halfway up the slope. There's the bottom of the valley over there. Now, a couple of reasons. Look at the gradients, not that steep. And obviously, this close to the dam that's situated down there. Okay, so that's a couple of reasons. So let's quickly go and answer the question after identifying some clues on the diagram. First of all, it's a gentle gradient, so it makes construction easier. Okay, and it's very close to fertile soil. And we can also mention it's close to the dam for water. And also close to the roads for transport access. You could have mentioned any of them and your answer would have been correct. Now, if you look at question 2.3.5, in a paragraph of approximately 8 lines, explain from a climatic point of view why the location of the farmhouse and the surrounding farmland on the valley floor is not ideal. Okay, when we look at this question, we need to go and have a look at the influence on valley climate on settlement. Now, I'm going to discuss question 2.3 with you. We just need to take a short break and then let's quickly get into it. See you in a bit.